Good morning, students. Today we will discuss our DOE worksheet 43, and today we will start our new chapter, periodic classification of elements. See, matter around us is present in the form of elements, compounds, and mixtures. And elements are the substance containing the atoms of only one type, for example, sodium, magnesium, gold, iron, etc. These are 118 elements known to us, and all these have different properties. But out of 118, only 98 naturally occurring elements. Okay, so need for periodic classification. Why there is a need for periodic classification? For that, the elements are classified so that they could be studied easily and in organized manner. The earliest attempt to classify the element resulted in grouping then known element as metals and non-metals. See, students, earlier all the elements are classified into two groups, metals and non-metals, and later further classification are tried out as our knowledge of elements and their properties increase. As the knowledge and properties of elements increase, they have further classified these elements into different forms. Then first scientist Dobrino came and give the concept of triads, so it is called as Dobrino's triads. Okay, in the year 1817, Dobrino, a German chemist, tried to arrange these elements with the similar properties into groups. When elements are arranged in the order of increasing atomic masses, group of three elements known as triad having similar chemical properties were obtained. The atomic masses of the middle element of the triad was roughly the average of atomic masses of the other two elements. See, if we take the example of lithium, sodium, and potassium, the atomic mass of lithium is say 6.9 and 23 and 39. Then if we add 39 with 6.9, we will get 45, and if we divide it, because we have to take the mean, if we divide it with 2, then it will comes out 22.8 something, right? So in this way it is almost nearly equals to, means 22.89, sorry, is nearly equals to 23. So this is the way Dobrino give the classification and name it as Dobrino triad. So example, take the triad consists of lithium, sodium, and potassium with the respective atomic masses, and the average of atomic masses of lithium and potassium is this, and this is roughly equals to the atomic mass of sodium. But it has limitations also. Dobrino could identify only 3 triads from the elements known at that time, all the elements known at that time, but this scientist made only 3 triads. Okay, so this system of classification into traits would not found it useful. Next scientist came into picture, that is Newlands, and he gave the Newlands laws of Octave. Newland arranged, I'll show you in a better way. Newland arranged then known elements in the order of increasing atomic masses and found that the properties of every 8th element is similar to that of the first element, and he compared this to octave found in the music and called it as law of octave. For example, the properties of lithium, sodium were found to be the same. See, the properties of lithium and sodium found to be the same, and it compare. He compared this with the musical 7 music that you can say it compared with the music sargam, okay, which is called as sa re ga ma pa dha ni. Okay, so but limitations of this also would be there, like it has applicable up to only calcium. Properties of new discovered element did not fit into the law of octave, right? New element did not fit in this, as well as this is applicable only up to calcium, and but at that time other elements are also there. So to fit element into his table, Newland put even two elements together in one slot, and that too in the column of unlike elements have the different properties. Even he just want to satisfy his concept. He put two elements together in one slot, and that too those who have different properties. So these are the limitation of Newlands. Let's do practice exercise. What is the need of classification? So you can write the answer from here. See, this is the answer. You can write it. This is the answer. And why the element were classified, so that they could be studied easily and in organized manner. Write down the three elements that show Dobrino triad. So you can give any example of this: lithium, sodium, and potassium, or any other also. Third question we have: Newland divides the element into horizontal law of 8 elements each. False. It is false. Okay. 7 elements in horizontal line. Okay. Next question we have: write down the two drawbacks of Newland. So you can write this answer from here. Drawbacks of Newlands. And fifth question we have: can the following group of elements be classified as a Dobrino trade? So if we take the first part, sodium, silicon, and chlorine, test 23, 28, and 35. So if we will add 23 plus 35 divided by 2, we have 58 divided by 2, that is 29. And this 35, this 28 is not equal to 29. So this is not classified as Dobrino trade. Take the next example. We have beryllium. Beryllium we have atomic mass 9. Magnesium we have 24. Calcium we have 40. Add this calcium plus beryllium divided by 2, that is 49 divided by 2, that is 24.5. This 24.5 is nearly equal, you can say nearly equals to magnesium. So it can be put into Dobrino's trade. Okay, so this is all about your today's worksheet. I hope you understand it. So thanks for watching. Take care, beta.